We're starting with two of the exact same 75-foot runs of coax, both of them with ferrite beads at the end. We're starting with two of the CHA spikes that are going to be used backyard portable here at my home in the HOA. We're starting with two CHA blank adapters. Both of them have the radial puck attached to them, and that's what we're going to use for ground radials. I guess you could say there's something a little bit different here. I'm using yellow wire and brown wire. It's just what I had. They're both bundles of 3 at 16.5 foot long for all three wires. We're going to start with two Gabil Radio 7350TC. They have the 3/8 by 24 at the bottom. That'll go into the CHA blank adapter. And then we put an antenna on top of these 7530T or TC coil antennas. And this is today, February 2025, the antenna that comes with these particular coil antennas. So what's going to be different today is that one of these 7350 TCs will get the typical telescoping stainless antenna, and one will get this. This is a carbon fiber antenna. That's right, you heard me, I did not stutter. I said carbon fiber antenna. Gabil Radio presented this idea to me months ago, and my first response was, you can't do that. In amateur radio, we always hear to be careful with carbon fiber masts because they interact with our antennas. So if you're hanging a wire, try to get your wire radiator away from the carbon fiber mast because it could interact with your antenna system. And when I told Gabil Radio, you can't do that, they basically replied to me, sure you can. They have come up with a special formulation of carbon fiber material. The very top piece of this carbon fiber antenna is a solid machined or extruded piece of carbon fiber. And what we have here is a telescoping carbon fiber antenna. And we're going to put this through its paces here at the HOA in my backyard, and we're just going to see exactly how this performs. Probably one of the first things I'm going to do once I get this set up backyard portable is get out, our rig expert and just see what SWR looks like. And I'm putting these up side by side, thus the reason for the exact duplication of all equipment with the exception of one variable. There will be one variable in all of my testing, and it will simply be these two antennas, one standard stainless steel that we've come to expect, and one carbon fiber. Will it work? If you listen to the first part of this clip, you heard me talk about February 2025. It is now early July 2025. This video hopefully will post by the end of the month of July. I feel a bit like the Galilean affair, the 17th century time period where Galileo had to defend his position on heliocentrism, that the Earth revolved around the sun rather than the sun revolving around the Earth. I'm dealing with sacred cows here. I'm dealing with paradigm shifts. I'm dealing with things about which I don't know the understanding of as it comes to being an engineer. I've admitted frequently on the channel I'm not an engineer. I am a mechanically inclined pragmatist. When I reached out to Gabil and I told them you couldn't do this, they assured me that absolutely you could do this. And then they sent me samples that proved out that, yep, you can do this. And now they have sent to me the finished products that are actually demonstrating that they pulled it off. So, I don't know the secret sauce. I don't know what their special formulation is of the carbon fiber mix. I don't know what coatings they have put on the inside or the outside of these particular sections of the carbon fiber elements, but what I know is it works. So if you're interested in breaking some paradigms along with me, then we're going to give you an early adopter discount code. Gabil always gives discount codes when I introduce a product for them, and that will be in the description below. It will be a 15% discount. So if you're looking at this video sometime in the month of July in 2025, then you have an opportunity to be an early adopter. This is a more expensive product. It costs more to manufacture this than does a stainless steel whip. So if it's going to cost more, it needs to bring a benefit. And the benefit that Gabil Radio says they're bringing to the table is nearly equal performance, which I'll demonstrate my perspective on that, lighter weight, and greater durability. So let's talk about all these things. Let's get into the Whisper maps. Let's get into the FD8. Let's get into the single sideband contacts, and we'll just see exactly if they pulled it off.
Kilo Papa 2 Mike.
Kilo Delta 4 Bravo Mike Golf.
84 Bravo Mike Golf 9K.
59 Florida Foxtrot Lima.
73.
The Gabil Radio 7350 TC coil antenna has a very small footprint, so I was intending to leave these set up as long as I could in the backyard without drawing too much attention here in the HOA. My neighbors have become used to watching me test the antennas for short periods of time, and fortunately they don't bother me. And because I was leaving these up for days on end, that's why I chose to use the Chameleon antenna ground spike and blank adapter, because I just wanted these firmly set in the ground. I didn't want any variation. I didn't want them moving. I didn't want them influenced by wind. So everything is the same. I am trying to keep them both the same distance away from the house. I am keeping them spread out between each other as well as close to my property lines on the end. All of the radials are set up in a similar fashion as far as 3 radials, 16.5 foot long, each all going in the same direction for the 2 different sets, 2 different antenna setups. And I've pulled my portamast down, which is a 20-foot telescoping aluminum flagpole / mast. I didn't want it in the backyard influencing RF in any way, shape, or form from either of these 2 antennas. And in this position is where I did all of my single sideband contacts, which just happened to be the evening of a contest, which was really convenient. This is where I did all of my FT8 operation, and this is where I did all of my Whisper map as well as Whisper data collection. So everything is as equal as possible, with the only differentiation between the setups being one had the stainless steel telescoping whip and the other had the carbon fiber telescoping whip. We'll look at the SWR readings between the carbon fiber and the stainless steel in just a second. But let's quickly look at these whips, how much they weigh, and what Gabil Radio's planned application is. They would love to replace all stainless steel whips on planet Earth. Highly unlikely that will happen, but I love the way they're thinking outside the box and giving us alternatives to think of. If nothing else, they're pushing the boundaries that make us think of different ways of accomplishing things, and who knows where this is going to go. So these were the 2 original prototypes that they provided to me, and the intention was that they would replace the stainless steel whips that are provided with their 7350T and TC coil antennas. So they've gone far beyond that, in that when I finally got the finished production, it is greatly different than what I had anticipated from the perspective of they actually sent me a whip that's a quarter wave 20 meters. And it's a little shorter than what we would expect to be. It's not quite 17 feet. And my first thing that I did when I got it was panic, and then the second thing I did was I went in the backyard. I was also doing some additional testing on their new powered screwdriver antenna. I took it out of their MK3 tripod and I put this quarter wave 20 on it. Nailed it with SWR, started making contacts with it that evening. And I don't know if this will be actually in the Amazon store when I place the first video and release it. This antenna will be, and the second one may not be. So I'm going to be doing a future review video on the quarter wave 20 meter antenna that they surprised me with. I had no idea they were making it. After I tested this, I said, hey, it works. They replied, great, we're going to make this antenna to replace these stainless steel whips. And then when they sent me the production, I had that replacement plus a quarter wave 20. So there'll be a future video on that, and I'll do some sneak peeks here at the end as far as SWR, as well as a couple of contacts. The screen was lighting up for me last night. So what do we have here? Let's get a look without me on the screen. So I'll leave on the screen here on the top what the thread size is on the top of their 7350T and TC. And whatever that is, it's an M10-1, I believe, but let's confirm it. And what they've created here is an exact replacement. So any current Gabil Radio antenna that you have, whether it's the 7530T, TC, whether it is one of their other coil antennas, the RPG, or whether it is their new powered screwdriver antenna, both of these will work on all of the Gabil Radio antennas that they currently manufacture and offer for sale. But their vision goes far beyond just creating a carbon fiber whip to replace their stainless steel whip. With every one of the carbon fiber whips that they're selling, both this shorter version and the quarter wave 20, they're including an M10-1 to 3/8 by 24 adapter. And so now you not only have, with both of these antennas, a replacement for a stainless telescoping whip for their antenna, their brand, you basically now have a carbon fiber whip for your Wolf River coil. You have a carbon fiber whip for your Mad Dog coil. You have a carbon fiber whip for your portable resonant vertical antenna. You have a carbon fiber antenna for your CHA Hybrid Micro or Mini. So you can see that Gabil Radio's vision is far beyond just replacing stainless steel whips for what they manufacture. They're giving alternatives for amateur radio operators across all brands of equipment if this is something that interests you. Let's get a look at our SWR readings, and then we'll go over and take a weight of, let's just say, this quarter 20 and compare it to others that are out there in the market. And then we'll compare these two, because these are truly the like-for-like replacements when it comes to the Gabil specific product. Let's take a reading of SWR 10 meters stainless compared to 10 meters carbon fiber. 20 meters stainless, 20 meters carbon fiber. 40 meters stainless, 40 meters carbon fiber. So there's no perceptible difference in the SWR from the carbon fiber to the stainless steel whip. So we seem to have a wash there. Before we get to the weight, one of the other things that Gabil Radio would be trying to do is to deal with the strength of the carbon fiber whips compared to our stainless steel whips. Now, the larger the stainless steel whip, when we get into say I've got the Intellitron 17-foot telescoping stainless antenna with me, you know, it's not going to bend and snap like this would. I bend this, you know what I'm going to be able to do with it. It's just going to snap, and all of a sudden in the field I'm in trouble. With this carbon fiber, when we take it and we put it up outside, it's going to have a great deal more flex and give to it than our stainless whips have, and that would be one of the benefits that Gabil's trying to provide for us. Let me talk a minute about how you extend and retract this. So once you take the top off, the tip, the very top section, is kind of below the top surface. So before you go screwing this into your mount, do take the first section and extend it up, and then you can screw this into your basin. Right now I don't have the 3/8 by 24 on the bottom, but you get the idea. And then you're starting with the top section, extending the next and extending the next. And you may see what I'm doing here. This is a lot more like a carbon fiber mast or a fiberglass mast than it is a telescoping stainless antenna, in that these two sections are friction fit. They very easily slide back and forth. So you're talking about a friction fit here. So each section you pull until it's firmly in place. And as you begin to use this, you'll get the hang of that. Now on the flip side, and I have a hard time extending this completely here in my shack because my shack is not that wide, you start at the bottom to collapse it. And you would collapse the first section, then you would twist and collapse the second section, twist and collapse the next section. You would never, on a fiberglass mast, start at the top from a 40-foot mast, right, and send it down the tube, because it's going to basically jam up with all the other sections that go down. So when you're extending, you start at the top and go up, and when you're retracting, you start at the bottom and come down. Let's get a weight comparison here.
Thanks, PJ2T.
Kilo Delta 4 Bravo Mike Golf.
Kilo Delta 4 Bravo Mike Golf, 59K.
59 Foxtrot Lima.
Foxtrot Lima.
Roger, roger.
Got it, thanks. Papa Japan 2 Tango.
This is the GRA-CF2200. It is 15 and 3/4 inches long. And in comparison to the whip that comes with the 7350TC and the 7350T, it is about 5.5 to 5 3/4 inches longer, fully collapsed. It's about 6 or 7 inches longer, fully extended. So this antenna, when fully extended, is 89 inches. So we got a couple of more inches over the stainless steel. But to be fair, it is a little bit longer if you're packing it with your 7350TC and the TC is not fully collapsed. So I would say this would be one of the only drawbacks of this carbon fiber whip to replace this stainless whip. Strength-wise, it is going to be stronger, no doubt. Performance-wise, well, you'll see that in a minute. It was actually a bit surprising. But let's talk about weight. I wouldn't call this a scale that I would bet my life on, but let's just get a comparison here on the stainless whip that ships with these. That is 2.9 ounces. And now let's get a look at the carbon fiber. The carbon fiber is 2.7 ounces. So again, very close to a wash, just slightly lighter than the stainless steel whip that comes with a 7350T and TC. This whip will work on their RPG. It will work on their new powered screwdriver antennas, the GRA-AT330. And this I just did a video on a couple of days ago. So we have a very versatile whip here that will get the job done on all of the Gabil antennas, as well as a lot of other competitive antennas when we add in this 3/8x24 adapter. Let's move on over to that big surprise, that 17-foot whip that showed up when this one arrived. To do a fair comparison between 17-foot whips that we're used to using in the US market, I did need to add the 3/8x24 adapter because that's what we have with our 17-foot long whips. This is the Intellitron version, and it comes in at about 24.5 inches in length, whereas the GRA-CF5200 comes in at about 26 3/8 inches long. From a weight perspective, what kind of difference do we have here? Let's get a look at the Intellitron 17-foot whip. We're at 14 ounces. Let's get a look at the GRA-CF5200. And it's bottom heavy because this is a metal connector. 8.6 ounces. So close to half, 8.6. 14. So there's an obvious weight advantage to the carbon fiber antenna, and I don't think that any of us would be surprised by that at all. And that would be one of the advantages of it. It is lower weight when we're packing out in the field. It is, what, just a couple of inches longer, so 1.5 to 2 inches longer. Performance-wise, I haven't compared these two whips that are 17 feet long. In all actuality, the carbon fiber whip came in at 16 feet, 9.5 inches. So it's not even the 17 feet that we would expect it. But again, I'll show you what the SWR looked like, and I'll show you some contacts that I made last night when I first set it up. I'll do a full review on that coming up in the next couple of weeks. If you watch the channel for any length of time, you know that I use Whisper to test antennas, and this is the ideal opportunity to test two different antennas because the only differentiator is the whip. Stainless on one, carbon fiber on the other. Everything else, exactly the same setup. I have two Whisper transmitters on my wall of fame, actually three. That other one goes up to 160 meters on the bottom. The top two I was testing on 20 meters specifically. So here is my Whisper map on 10 meters, 20 meters, and 40 meters. But what I really want to draw your attention to is the data set that I pulled from the Whisper transmitters. The maps are just of the carbon fiber. The data represents both the carbon fiber and the stainless. So I'm looking at the data in a number of different ways. Notice there's a test 1 carbon, a test 1 stainless, a test 2 carbon, a test 2 stainless. This is because I ran Whisper over 2 days, and in between day 1 and day 2, I switched transmitters. I put the antenna on the opposite transmitter. So each antenna ran one day on each Whisper transmitter. That way, if there's any anomaly in my transmitters, it basically could have evened out when I swapped. I combined the data, I ran my statistics. Here are the statistics. We're comparing the carbon fiber antenna with the stainless antenna. Bottom line, total number of contacts. The carbon fiber antenna accounted for 50.4% and the stainless 40.9%. Total number of contacts on the carbon fiber, 13,008 versus 12,798. So the carbon fiber just edged out in the total number of contacts the stainless. The stainless edged out the carbon fiber in unique stations. There were 310 unique stations from the carbon fiber and 337 on the stainless. Each station could have resulted in multiple contacts over that period of time. So 300 stations resulted in 13,308 contacts. 37 stations resulted in 12,798 contacts. It's like making the same contact over and over again with the same station at a different time of day. Here's the interesting thing when you look at the carbon fiber statistics versus the stainless statistics. The theory around using Whisper is trying to get an indication of how propagation is working. So you can take a look at a map and you can see where your signal is being heard by a Whisper receiver. I have Whisper transmitters. So if I have two antennas that are almost identical with one variable, I could look at the maps and see if there's any variation. There was virtually no variation between the carbon fiber map and the stainless map, and that's why I didn't bother flashing the stainless map. If I overlaid them, you really could not tell the difference between the two. So I had to go to the actual statistics on the screen to my right, which is why I'm pointing in that direction, to try to find if there was any variation one over the other. Whisper stands for Weak Signal Propagation Report. We're not even measuring power in 1 single watt. We're in milliwatts. So it's not representative of whether or not you can make a single sideband contact, which takes more power than what a Whisper transmitter is putting out. It's an indicator. But there are statistics that seem to indicate that when you look at the Whisper data, anything with an SNR above 0 has the likelihood of making a single sideband contact. And even in negative SNR numbers, it's been demonstrated. Josh KI6NAZ did a live stream one night where he was actually making contacts, I think, as weak as -10. But it's been a documented fact that when you're 0 and above signal to noise ratio, that you absolutely are capable of making single sideband contacts. And I think what's interesting to see here is that the carbon fiber held its own. When it looks at SNR signals that were reported back, 0 and above, I have 46 versus on the stainless side, 43. Now that's not anything massive, but when you really take a look at the comparison of the performance of these two antennas, it's hard to say that the carbon fiber underperformed in any way, shape, or form. Now, my single sideband contacts, those were 100 watts through my transceiver. I'm about to flash some FT8 information because this antenna did absolutely fantastic on FT8 as well. And I was basically throwing 100 watts at it through my IC7300 because I wanted to see if I could burn up the antenna. Now, I don't run FT8 like some of you do, hours on end. I typically pop FT8 up for 15, 20, 30 minutes because I use FT8 for testing antennas and for nothing else. But when it comes to weak signal propagation report, FT8 and my single sideband contacts, I just can't find any flaw with this carbon fiber antenna. That kind of makes me scratch my head. We're well into this video. We're getting close to the end. I wonder how many people have already clicked off and gone, this guy is nuts. And who knows how many people have unsubscribed and have jotted an interesting memo in the comment section. I acknowledge this doesn't seem like it should work. Carbon fiber is used many times as a barrier to RF transmission or leakage. So it almost acts like a Faraday cage in many applications in electronics. So Gabil Radio has taken those properties and converted it over into a radiator that I can't find a flaw in yet. So do comment below. Give me your thoughts. I hope some of you join me as an early adopter and give this thing a go because, well, let's just have at it and see what happens. So I've had a blast with it up till now. I've got a 17-foot whip, or just less than 17 feet, 16 and a half or 16 and 3/4. We'll give that a go. Let's take a look at FT8 and I'll give you my final thoughts. I think you already know. FT8 10 meters, PSK reporter 10 meters. FT8 20 meters, PSK reporter 20 meters. Again, you can see I'm at a 15-minute interval. FT8 40 meters, PSK reporter 40 meters.
You are 59500. Thank you. Yui Papa 483.
Kilo Delta 4 Bravo Mike Golf.
Kilo Delta 4 Bravo Mike Golf 59500.
59 Florida Foxtrot Lima. All of the testing you've seen up to this point, single sideband, Whisper FT8 have been with the 89-inch carbon fiber whip and the 7350TC coil. This is one of my favorite coil antennas. I love all of my coil antennas. I bring this up because I want you to understand that with this particular combination, you're going to be looking at quarter wave on 10 meters and down. If you want to get on 6 meters, I guess you have to start thinking about a half wave. And I've never done any testing like that, half wave, 3/4, or full wave on any band, but now's as good a time as any. You need to understand that with these two antennas, and we'll do a sneak peek on this one right now, these are either all or nothing antennas. In other words, because of the design, you can't collapse these on themselves to get them resonant on other frequencies, other bands. It's all or nothing. All sections need to be touching each other to have continuity and send out the RF. So when you set up this particular antenna, which is just under 17 feet, and like I said earlier, that got me confused right away, and when I went outside backyard and set this up with my radials, I achieved an SWR that I was quite happy with, and then I went off and made some great contacts. FT8 was just nuts, and Sierra 51 David X-Ray, always somebody you can count on making a contact with. But you're not going to take this this whip, this 17-foot whip, and collapse it down for resonance on other bands. So if you're going to use this, it's full extension, and either on a matching unit or on some other type of coil, whether it's on top of the 7350TC or one of the other coils that I showed earlier. This will work with them. And then on some of the higher bands, you might be having to think about half wave, 3/4, or full wave. Putting this on a matching unit, then you could be multi-banded with a tuner. Haven't tried that yet. Again, I haven't done anything with this one except set it up as a resonant 20-meter antenna. Let's get a look at that right now.
Bye-bye. Thank you.
Kilo Delta 4 Bravo Mike Golf.
Kilo Delta 4.
Kilo Delta 4 Bravo Mike Golf.
Kilo Delta 4 Bravo Mike Golf. Thank you for the box. About 5959 with me. Go ahead.
You're 5'9" here in Tampa, Florida. Giannis, have a great day, and thanks for the contact. 73, friend.
Got you through the band at 73, Bob. QRP station, your call.
I say be sure to leave your comments below and tell me what you think, but that's probably been happening this entire video long. I am privileged to be working with some really awesome antenna manufacturers. You see, I am very selective. Thanks, Gabil Radio, for giving me the opportunity to introduce this, and let's see where this goes. Hope you all enjoyed this today. Talk to you soon. 73.